So first things first, with JavaScript, you have 6 data types. So data types are what enable a programmer to perform the logic in the application. It's not really what controls the logic, but it's a way to control the data. And in JavaScript is very simple because it only has 6 data types. In ECMAScript 6, there's 6 primitive types and 1 reference type or an object type. But let's not focus on the 6 types of ES6. Let's just focus on the basics. So you have the 5 types. The 5 types are so the Boolean type, starting with that one, is just a true or false value. So whenever you have a condition and you wanted to evaluate to true or false, you have the Boolean type. For example, if we declare a variable, we can see that it is a Boolean type. And if we want to see the value of that type, we can see that it's true. For a number, you just assign a number. And so we just assign a number like this. And we can say the same thing, just like we did for that. And we can say, and you can see that the type of B is number and the value is 10. And we are going to get into more detail with these variables, but for now, let's just focus on the types themselves. And as we go, we can get into more detail about each of these types. For now, just know that they're there. And the same thing for anything. For null, actually, and let's clear the screen. Is that Control I or Control L? So if we run this, you can see that it's of type object, but that's really one of the quirks. It's not truly an object, but it can be thought of as an object. And undefined, as you can see, the type is undefined and the value is undefined for a variable that we haven't assigned a value. The variables get their types when the value is assigned. If a value is not assigned, then the value is undefined. So in this case, A does not have a value, so it is undefined. And if we make it a string, if we make A a string, then you can see that it's of type string and the value is Joe. Also, strings can be assigned the value by using double quotes. So you can use a string and you can use single quotes or double quotes. Let's see, what did we cover? We covered string, we covered undefined, we covered null. Let's look at null once again. And let's look at number. So as we get into more details, let's examine each one of these values and see what we can do with them. Let's examine number first. So let's say, for example, we assign a value to number. as you can see in this case, we have taken the value of A and B, added them together, and came up with C. So now C has the value 15.5. For Boolean, it's very simple. You either assign it a true. Let's clone our own copy because this is giving me problems. Let's clone our own copy. Okay, good. So when we do this, clone your own copy, Control-Shift+S. How did we end up here? Wow. Okay, let's not do that. Let's get out of here. Somehow we ended up on someone else's console, which I'm not sure how that happened. So let's clear this out. Okay, so now this is our console. Okay, so now we have the value, which is A, and the variable is A, and it's set to true. And we can also set it to false. And this becomes very important for a lot of different reasons, because once you start executing conditional logic, if this situation is true or if that situation is false. But we could also do something like this. We could say if 10 greater than 11, and that statement in this case is false, so it should give us false. So let's clear the screen and let's see what it does. And let's do it again. Okay, and it gives us a value false because 10 is not greater than 11. But if we were to do something like this, how is this happening? Okay, it's not doing that anymore. So, okay, we're okay. Okay, so we are here. So now the Boolean value, as you can see, is true. And we'll get more into conditional statements like such as equal, equal, or this type of thing. But for now, just keep that in mind. Just the Booleans are for true or false conditions. And let's examine the strings a little bit closer. So a string would be, for example, if you said like a name, and you could say and you notice that it concatenated the values together. And the plus is not adding strings, rather it's joining the string together. And the strings actually have a lot of functionality in them, and you can do a lot of different things. We will take a closer look at the strings further down in this short session. But for now, just know that the strings are there, and you can join them, and you can do a lot of interesting things with those. So then we finally get into object, and object is for all the reference types in JavaScript. So a reference type is usually defined something like this. Of course, that's just an empty object, so it's not going to give me much. But if I was to add attributes to the object, and don't worry so much about the attributes at this point, just know that an object usually has attributes, and attributes can be anything. Any valid type in JavaScript can be an attribute. So think of them as properties. For example, if you had a car, and let's do a more realistic example. So we have car, and we had make, for example, and that would be a string. And let's say Ford, and let's say model. And notice that I separate my attributes with commas, but I have key value pairs, the make, and then colon, and then a value. So the model would be, let's say, what's a model? So F-150. And then we could have year, and let's say that for year we had a number, 2016 or something like that. And when we console log that, we can console log it like this. So let's clear this, console log it. And when we console log that, it gives us the values. Now we can access, for the object, we can access the properties individually like this. And we can access every property. So we could say And in JavaScript, all these values can sometimes be combined. For example, if we have these different types, let's say we had a Boolean equals true, and we have a string, and then we had a number, a number 10, and we actually were to join them all together, and we said D equals A plus B plus C plus, well, that's it. And so when we go to console log that, and you notice that it joined them all together and formed them into a string. And this is something dealing with coercion, but we're not going to talk about coercion just yet. Just keep that in mind as we go along, because other languages won't actually allow you to do this, but JavaScript is really good about allowing you to join different types together and converting by default into a string. We will get more into that as when we cover coercion. So for now, just keep that in mind. One thing that I didn't discuss in JavaScript, and I don't even know the rules, I'll be honest, but just know that for variable names, JavaScript, you can use anything for a variable name. Typically, what you use for a variable name is any letters and symbols, but I believe you have to start off with a character or underscore. You can't start off, for example, with that. See how I get that error? But I could say D1, and that works fine. But 1D does not work fine. I can also start my variables with this, and that works fine. But typically, there's a special use for underscores, and I'm not sure that we'll get into that topic. Just know that they're there, but it's a way for JavaScript programmers to let each other know. It's kind of a symbol to say, hey, don't use this variable like this because the underscore has special significance. In other words, it's a way to protect things, but it doesn't enforce any rules. It's just a way for programmers to know not to touch those variables, not to modify them. And we can get into that when we start talking about objects. For now, I think that's enough for the types and the variable naming. So now let's go on to the next session and get into functions. A function in JavaScript is different than other languages well, in particular, the static type languages, because JavaScript functions always return a value, even if that value is undefined. However, the data type does not enforce any type of contract. So for example, a JavaScript function is declared in the following manner. In this case, the function called add is declared by the keyword function. And once we declare that function, then we can call the function by calling it with the parentheses, and it returns whatever value we tell it to return. Now, in some cases, you may have a function that returns nothing, for example, like this. So in this case, the function would still return a value, even though it does not explicitly appear to return a value. So for example, when you do this, what you get is undefined. So it is returning a value, it's just undefined. So functions can actually have parameters. So for example, a function can have x, or let's do a and b. And so for example, the parameters for the function, it accepts two parameters. So we can say 5 plus 6, and right now it's not doing anything, but let's just say that we added something together. And now it's going to add those values and return the sum of those values. One thing about functions in JavaScript is that they don't enforce the number of parameters that you assign. So for example, I can still call this function with only one parameter. However, it will give me something that I don't desire. As you can see in this case, it returns nan, in other words, not a number. So even though the function is valid and it allows me to do that, it does not return anything. So one way to get around that, I could actually test to see if I actually have a value in the B, because the B is really undefined. So if I say, for example, if B return A plus B, and if not, you notice it's not going to return that anymore. In this case, it returns undefined. The reason that it returns undefined is because it's not jumping into this if statement, right? Because undefined is a falsy value, which we can get into further down the lesson, but about truthy and falsy values. But since B is undefined, it's not going to execute the statement. Instead, it jumps out and returns undefined. So by default, we could say if it's that, return that. Otherwise, return A. So if we did that in this case, it would just return A. So for example, if we did this, you notice that it returns 5 because we actually tested for the value. Likewise, I can actually call the function with more parameters, which is something interesting in JavaScript, because you can call a function with additional parameters. So for example, I can call it like this. And if I'm not prepared to accept those parameters, it would simply ignore the parameters. So for example, if I called it like this, right? The function still works, but it's really ignoring the third parameter, and the function still works fine because functions do not require a particular contract. So for that reason, now there's ways to get the values to extract the additional parameter with something I believe it's called args. We'll get more into it once we cover functions in more detail. We cover that topic. So for now, just know that you can really call it with more or less or fewer parameters. So the function is defined in that manner. Another thing about functions is that functions in JavaScript are first-class citizens. What does that mean? Well, anything you can do with any object in JavaScript, you can do with a function. So you can actually assign a function to a variable. So let's take a look at that. So let's say that instead of having our function defined in this manner, we had our function defined in this manner. So we can create a variable, name it add equals function. And since we already have the name in a variable, we can take that function and still call add, and let's get rid of the extra parameter. So in this case, it'll still work. And so the function still works. However, there is one big difference between naming it, and you may wonder, well, why name a function when you can just name it or when you can declare it? Notice this difference though. When I do something like this, when I say, for example, if I take this code and put it up here, if I do this, my function is not going to work because the function variable has not been assigned a value, the value being the function. So it's going to give me an error actually, because it's not going to recognize add as a function. It's just going to recognize it as a variable. So let's just run it and see the error. And you notice this add is not a function. Well, you can see clearly that it is a function, but it just hasn't been assigned. It is not that add that you may think that in other languages, well, the function doesn't exist until you've created it. But there's something called hoisting, and we're going to talk about hoisting in more detail. However, at this point, just know that hoisting is there. And notice what happens if I rename my function. If I don't have it like this, if instead I declare it as a function, notice that it actually works. So if I clear the screen and then I run it, notice that the function actually works. Well, the reason for that is because when you assign it to a variable, it separates the name from the definition and it doesn't know what to do with it. And you may think that, well, maybe it's because it hasn't been defined. However, if you look at this and you say add equals function, right? And you say, so when we do this, you will notice that it says undefined. So the first console log tells us that it's undefined, and the second one actually executes the function. You may be thinking, well, undefined is because it hasn't been defined, hasn't reached it. However, notice what it does if I had a different function. So let's say I called it multiply, and notice how I get an error because multiply has not been declared. So it's going to give me an error. And notice how mul gives me an error, whereas add actually just tells me it's undefined. So there's a difference because of hoisting. We are going to get into hoisting further as we go in the course, but for now, just know the differences between creating a function one way and creating it a different way. Functions, since functions are first-class citizens, functions can be passed to other functions. So for example, we can have the function add, and we can have another function called something else. Let's say call the function multiply. So let's say that we had a function called multiply, and it takes a parameter a and b, and it takes a parameter to let's call it add, and let's call it x add, just so it has a different name. It doesn't need it, but let's just say, for example, that we did that, and let's say that we took that function and we said x add, and we passed it, and we say x add. Yes, that's true. A plus b times x add. X add a plus b. So we're taking the values, adding them together, and multiply their sums together. So then we have to, of course, return this. And so we're going to do in this case, we are going to multiply the values, add them, and multiply them. And what we have to do to call this function multiply, we just say something like this. Ten times 5, right, which is going to actually add here 10 plus 5, which is 15, and it's going to take that and multiply it times another 15. But of course, we have to pass it a function. Now, x add, we can pass add to it. So if we pass add, it's going to pass this function into it. So x add becomes the add. So when we run this, and we have to actually log it, and you notice it gives us 225 because we can actually pass a function. In the same way, we can return functions from other functions. So let's say, for example, we had some kind of factory, and we have a function, and get mystery function. Let's say, for example, we had this. And notice I am returning a function that multiplies. And so if I was to call this, and that should give us 20, because mystery function is actually returning a function. I take that function and use it, and it's actually returning this. So when I execute the function, it will give me this. So let's clear it and run it. And you can see that it gives us 20. So anything you can do with a variable, a normal variable, you can do with a function. One interesting thing about functions, and when we get into an example, and we can get into functions where we have, for example, a function, and we want to implement some sort of template pattern. And you may know this in callbacks and things like that. So when you have a function that has a callback, it means you're deferring the execution for down the road. So let's just give a quick example, and let's create a filter function. So let's say that we haven't covered arrays, but let's cover arrays really quick. And arrays are nothing more than a sequence of units in memory. So let's say, for example, we had an array of numbers, right? We call it, let's call it ages. Let's say we had a collection of ages, and we have an array. Now, arrays in JavaScript, we can have 5 and 6 and 7, and arrays can really take any type in them. So arrays can have types, and they can have mixed types, but for now, let's just have numbers. And so when we have a function, and let's say that we had a function called filter, and it's going to filter those values, so it needs to take an array, and we just call it ARR, and then we give it a condition. Let's just leave it at this for now, and let's say that we didn't have truly a condition that if we wanted to, for example, filter our array, and let's say we wanted ages greater than 10, right? So we can do for loops. And let's say we have a for loop. And if we have a for loop, we can declare a for loop like this. So this is getting into covering a lot of ground that we have not covered. But don't worry about that, because we are going to cover every one of these concepts in more detail just to break this thing apart. And then we're going to come and revisit each one of these topics in even greater detail. So for now, just know we have a filter and we can pass it an array. You notice that as we're talking about functions, the function, this variable is being declared inside this function. So we can name it anything we want. It doesn't have to match the ages. We're going to be passing the ages into that array. However, for now, we just name it array. So we are going to create a new array that we are going to take the values from this array and push them into this array. And for this function, we are going to just extract all the values greater than 8. So it's going to give us a new array with 9 and 10. So let's go ahead and get started. We declare an empty array here, and we are going to create a for loop. For now, just know that the for loop has 3 statements. So it has to have an initializer, and I don't have to declare the I here. Since we have to loop through a certain number of elements, we can simply say var I, and it's declared but not defined, and then here we're defined and we set it to 0. We say where I is less than, and arrays have a property called length, so we can say r.length. And many times it is recommended that you actually get the length first, because an array can actually change, so we can say length, and we say r.length. And we go through, and I don't want to do that. And you notice that I haven't been using semicolons. And if you come from a language like C++ or C or anything like that, you may be used to doing this. In JavaScript, that is optional. One caveat, if I had another assignment, for example, if I had var I here and I wanted to declare then another statement, then I would need that. Another way to do things in JavaScript is to simply say something like this, and to have commas separating this stuff like this, right? So that's common. But for now, let's just stick to the basics and just declare each one in a line like this. So we can say I is less than length, and that's a Boolean condition. And then we have the I++. And I++ is just a way of saying I equals I plus 1. So it's like saying, I is, for example, if we say I equals 0, and if we say I++, we're really telling I increment by 1. Since it's an integer, it'll increment by 1. And in most languages, just about every language I can think of, and the ones that I've worked on anyway, usually do it something like this, I plus 1, right? So you say I, whatever I is, if it's 1, you're going to say 1, right? I equals I, which is 1, plus 1, so it increments to 2. It takes the value that it adds and assigns it to 2. But shorthand, coming from the C language, you have plus plus. And that takes it and increments it. So what it's going to do in this for loop, the way we're defining the for loop, you notice that we have the parentheses here. We have another set of parentheses here. And then we take that and take those values and we say I equals 0. And then we separate it with a semicolon. And then we have a condition while I is less than length. So it starts with 0 and it's going to increment here by 1 to the array length. So in this case, our array length is it's 6 long. So while I is less than 6, so it's going to go all the way up to 5. Remember, it's starting from 0 because the array is 0 base. 0, 1, 2, 3, 4, and 5. So we have this array, and now we have a loop that can go through the entire array. Now, what do we want to do in this case? We want to say an if statement, and we haven't covered if statements, but just know an if statement, it's very similar to a loop. You're required to have parentheses. And we just put a Boolean condition in this place. So in this case, we say if I is greater than 8, and we can put the parentheses around it. Not the parentheses, but the curly braces. And if it's greater than 8, then we take our new array, which is what we defined up here as an empty array. And the array has actually a lot of functionality built into it. For now, we're just going to worry about how to add, in other words, how to append items to the array. And the way to do that is to call push. and pushes a method. Since it's a function, but it's a member of the array class, so it's a method, and we can push the value. In this case, we push the value from the original array, and we access it with I. So not I. See, I have the actual value wrong here. What I should have is ARRI, which is the element, whatever element I'm on, whether it's this, or this, and it's going to push that. If it's greater than 8, then it's going to push that value into the new array. One final thing that we have to do in this function is return the value. And there you are. Now we can filter the array, and we should get all the values greater than 8. So now we say, okay, it doesn't like it because I didn't put a return there. So one thing about when I said about semicolons, you got to be careful because even though it ignores white spaces, if I was to do this, it will return undefined. So that's an error. So once I return this, then I can say console.log ages. Well, actually, I'm going to call the function filter ages, right? And it should give me the ages greater than 8. So it's going to give me 9 and 10. And we have that there. So now let's reduce this a little bit. So we clear it and we run it. And what did we do wrong? Filter ages 20. What? That's not right. Filter. Okay, we have filter array.length. We have ages, return new array, new ARR push, new ARR. Whoa, what is going on? Definitely not what I'm expecting, so I'm looking at this and seeing what is wrong with this. Okay, let's see. Okay, so let's see. We have 0, I equals 0, I less than len, I plus plus, if ARR greater than 8, new ARR. Push, so we have this value, this name here, and we push the value, we push AR. And maybe we need to call this, maybe filter is a keyword. So let's go ahead and do this. Let's try it again. There we go. I think filter is a function already in JavaScript, and it didn't like our redefinition of filter. So there we are. We have 9 and 10. But what if we wanted to have something where we want to filter on maybe even numbers or maybe numbers less than 8 or something like that? Well, we would have to create another function with this. But there's a better way. And that's when we get into the function callbacks that we were talking about. Since we can pass functions into here, we could pass the function that makes that decision and say check condition. We just call it a long name. And instead we say if check condition, and we pass it whatever the element of the array is. So we say ARRI, and whatever the check condition is, then that's what it executes. So if our check condition, we wanted to have, for example, a function called greater than 10, like this, equals, and we could define a function, right, greater than 10, and it's going to accept an element, and we just return x greater than 10. Oops, like this. At that point, we can pass ages greater than 10. And we're passing the function greater than 10, and it should give us everything that's greater than 10. Of course, there's nothing greater than 10. Let's do greater than 7. Greater than 7. And you notice it gave us everything greater than 7. But there's even a better way of doing this, where we don't have to actually define this function. We can define an anonymous function right in line. So we can do this. And we can, at that point, get everything. Well, once again, I shouldn't do greater than 10. I should do greater than 7. So I can clear this, and it will give me the same results. Okay, what did I do wrong? Oh, I don't have a return statement. And so there you are. It gives me those functions. So now I can actually use my filter with any condition. So my filter can actually have any condition. And actually say whatever if X, and let's say that I wanted all the even numbers. Because now we haven't talked about the modulus operator, but think of it like division, and it's the remainder. So for example, anytime you have a remainder of 0, that means it divides evenly by 2. So if I divide a number by 2 and the remainder is 0, that means it's an even number. So in this case, it will give me all the even numbers. So let's go ahead and run that. And that is one way that you can pass functions. And there's even a better way in ES6 to do this. We can look at a quick sample, but we won't discuss the arrow functions in detail. We could actually take and convert this into simply say X in arrow notation, and we can say X mod 2 equals 0, which looks a lot cleaner and it will work. And let me see, I don't think I have all my parentheses, so let me put my parentheses there, and it should yield the same results. And you notice that it does. So that's even a cleaner way than actually defining a function. But that's something that's in ECMAScript 6. So, older versions of JavaScript won't accept that standard. So that is one way to pass functions. Defer execution, or if there was a callback or something that it needs to execute, then you just pass that condition in. And you can do that for swaps. You can do that for a lot of different things. So that's one way to pass that, and that's one way to execute it. And in reality, a lot of these things are already created for you, either in the language and somewhere in the language, or many cases, there will be a library that actually handles a lot of this stuff. So you won't have to recreate this yourself. But one thing about this is it's really difficult to talk about arrays without talking about for loops. And it's really difficult to talk about for loops without talking about arrays, because usually you have some kind of array that you're actually looping through. So there you are with arrays. Now, let's take a closer look at arrays. So we have this code, and let's just save this code for now. Let's take all this code and save it. Let's call it callbacks. Let's just save that for now. And let's talk a little bit more about arrays. So arrays are pretty interesting in JavaScript in that they allow you to group things together. So you can have an array, for example, you have an array of things, right? So I can have an array. What's interesting about JavaScript compared to other languages is that you can mix types. For example, I can have, in one case, a number, another string, and maybe a boolean, and even, for example, an object, any object, and I can have, even within that, I can nest other things, arrays within it, and then I can have, for example, even a function in the array. So I can have a function that, let's say returns 1 or something like that. So now when I actually console log my array, let's run this. You can see that my array has all these items in it. So if I was to actually if I wanted to execute the function here, I would have to count my indexes. So 0, 1, 2, 3, 4. So we know that the function is at 4. So I can do that, and actually I can execute it. So let's go ahead and execute function, and it should give me a value of 1. And it does. So those are arrays. Now arrays are interesting. Typically, you don't want to use arrays like this. There may be a good reason, but typically you don't. In other languages, you typically don't, and I wouldn't recommend it. You usually want to put like items in an array. So let's say, for example, that I had an array, and I have an array like this, and I have, let's say, Joe, and let's say I have Mary, and I have John or something. So the array allows me to do certain things right out of the box, right? So for example, I can add elements to an array, and there's a lot of different ways that I can add elements. So I can add an element to an array by using the word push, excuse me. And you'll notice that David was added. Now I can remove items from the array. I can use push and pop, and it behaves like a stack. So a stack if you're not familiar with stacks, think of a stack of like a stack of dishes. I don't know if you've ever been to those cafeterias where they stack the dishes and they push them all the way down. And, the first dish that goes in stays at the bottom. And the first dish that comes out is the one that's at the top. So they always come out from the top of, maybe you never get to the bottom one. If they keep putting dishes on top, you're always pulling from the top. So that one dish, unless they completely run out, is never going to run out. So for example, if I say push, then I can also pop. And I can actually say array pop. And it's like David never went in there. So when I do this, you see that David got pushed in, but then it got popped right back out. If I was to call pop more than once, it will also pop John because John is at the end. So it'll pop John, and so John is going to disappear. Uh-oh. It didn't pop John. Array push David. Okay. Oh, it pushed David. It popped David. It should have popped John. Let's clear it. Oh, that's... no. Pop. It should have popped it. Let's see. Let's clear this. It did. Okay. It should have popped it. It popped it twice. It did pop it. Okay. I don't know why it wasn't demonstrating that. But you notice that it popped. And if I pop them all out, it's going to pop them. The other thing about pop is that it will return the value into it. So for example, we said A, and this one would be David. And we could call it N1. And we could say var N2. And we can actually console. Let's console the first one that got popped, which should be David. And then the next one would be John. So you notice it popped David and John. So that's how you can add to the array. Another way to add to the array is you can simply add, and which I don't recommend, but I don't know, I don't think it's a good practice. You can also add items like this. If you know how many are in the array, you can actually say, for example, 0, 1, 2. I can say 3 equals David. And then I can console log the array. And you notice I added something. And I could continue going with the array and adding items to it. Oh, I added David twice. Let's call this guy, what's it, Don or something like that. Just clear it and run it. That's another way to do it. Now, well, what if you want to remove from the beginning of the array? If you want to remove from the beginning of the array, there's something called shift and unshift. So you can say array dot shift. I believe this. Let's take a look at our array. Let's see what it does. You notice that it removed Joe. So in the same way, it will actually have, it'll shift. And you notice that it shifted Joe and it returned Joe and stored it in A, and then we're console logging A. And the same way you can insert to the beginning of the array by simply saying let's say we added K to the beginning. So we remove Joe here and we insert at the beginning K. So now our array is going to have K, Mary, and John. And you can see it does it. Now there's a lot more with arrays where you can split arrays. You can join the array. You can actually say array.join. And it will join it into a string. And that doesn't change the array because the array will still be the array, but it just joins it temporarily as a string. So there's a lot more functionality to the array. Of course, you know, you have the length, and it gives you the length, and you could access any element within the array. But if you really want to know more about arrays, I believe that array, if you Google array JavaScript, should take you to Mozilla because that's really the best place to get it. So if you go here, you can find all the functions about arrays, all the functions, well, methods. The length, the prototype, of course, it has that. But let's see, you can have index, you can have for each. For each is something important in it, in the array. And we can cover that, but I really rather not cover it. You can see how the for each works here. And basically, it goes through each item in the array, but it does it as a callback. So it doesn't truly, there's no way for you to really break or continue, which we haven't covered, but you got to be careful with the for each. You can actually modify the array. So we're not going to cover that. That's a little bit more advanced topic. So we're not going to cover that. So that's the array. Now, one thing we didn't cover is conditions. So let's talk about conditions, if statements, right? Let's say, for example, that we have some logic and we have to determine if a certain condition is true or if it's false or whatever the case may be. So when you have a condition, that's where the real programming takes place. If we didn't have conditions in a programming language, we wouldn't be able to execute any logic. We wouldn't be able to make decisions. The decisions are based on if statement, if else. So if we have a condition, right? Let's say, for example, let's go back to our arrays, right? Let's have an array let's have an array of students. Let's call it kids. No, let's call it persons. Let's just say persons. And let's say we have an array of persons, and let's create some objects, and we'll have name, and let's just give it a name and say Joe, and let's say that each object has an age. Typically, they would have a date of birth, and then we have to calculate the age, but let's not get into that. Let's just go ahead and give it an age, and let's say, for example, we say this guy is 17. So one way to separate it to make your code cleaner is to kind of have the objects defined like this, and then just separate them by commas. And if your objects are really big, in this case, my object only has 2 attributes, name and age. And these attributes can really be anything we want. So in this case, let's say we have Joe, and let's go Frank, and let's have Mary, and let's have Jane and David. And let's give all these ages. 17 is fine. Let's go 21 and 18 and 23. Oh, 23. And again, 17. So if we wanted to do some kind of logic, and of course you already saw how we execute the for loop. So we execute the for loop, and so all we're doing here is we're going through the for loop, and we can loop through all the persons, right? So one thing we want to do is, as we loop through all the persons, we want to log whoever's older than 18 or older. So here we can say console.log, and we can log the person. We'll just say persons. We'll log the entire person. We won't even do the name or anything. But we need a condition. So in order to do that, we say if persons I dot age greater than 18, greater than 17. And we can have our body inside the if statement. So the if statement, you notice that it has to have a body. Now, if you have one statement, you don't need it. I just always recommend using the curly braces. So this is going to log any persons that are older than 17. This is our logic. So let's see if this even runs. So you notice it gave me everyone that's older than that. Frank, Mary, and Jane. So Frank, Mary, and Jane are older than 17. But let's say, for example, that we had another condition where we also knew their gender, right? So let's call it gender. And let's say that it's male and female. Male. So let's say that we had an additional condition. In this case, we want to check to see if, for example, if they are greater than 17, or, and let's make one of these girls younger. Let's make her 15. If they're older than 17 or female, we don't care if whatever age they are. If they're female, they're okay. So we're gonna, let's say for example, we're allowing them into something, and we say, okay, if they're young, we still allow them. So the way you do an or in JavaScript is you use this symbol, which is the 2 pipes, and we can say, or if persons are greater than 17, or persons I.gender equals female. And so that should give us all the females, right? And all the males that are older than 17. So So that would only be Frank. So let's clear this and let's run it. And it gave us Frank and Jane. Now we can also do this. And now what if we wanted to do a different kind of logic? We want them to be only females, but only females that are older than 17. So that would be an and you use this double ampersand symbol to say, okay, they have to be older than 17 and they must be female. So both of these conditions must be true in order for them. So it's only going to be females, and only if they're older than 17, which that would only make, let's see, Jane would be the only one that should show up. And there you are, Jane is. And now I can combine as many of these as I want, right? And I could have ands and ors and everything. One thing you have to keep in mind that if I'm doing ands and ors and a bunch of that, it can get very complicated. And you don't necessarily want to do that. Maybe you want to separate that stuff out into variables. But even if you do it, then you want to be able to separate them with parentheses. For example, if you had another or, because for clarity, now there's rules of operations that it's going to execute, but just to make it clear what you're trying to accomplish, make sure you put, if you have more than two of these, then you want to have parentheses around these groupings and everything. There's another thing that you can do, which you can use the negation symbol, and you can actually say, for example, like this, if they're not female, this is not. So the gender is not equal female, so that would mean that every male would show up there. So I can do that, and you notice Joe, Frank, and David, which are all the males, and they show up, right? So you can do that way. And of course, you have the equality operator, where you can have if it equals female or male, right? And you notice if you're coming from another language like C# or JavaScript, then you may actually have, not JavaScript, I'm sorry. If you come from a language like C#, Java, or C or C++, you don't have this triple symbol. And we'll get more into that, but there's something called coercion, where, for example, if I was to say, if I don't use this, it coerces a value into the type. So because JavaScript does not enforce the types that are on the left and right side of this symbol, but it will enforce them if you have the triple, right? So if you have this triple symbol, then it will enforce it. For example, like if I had 21, if for example I had age equals 21, like this, then it's going to give me anybody that's equal to 21. In this case, it's just Frank. So it shows me Frank because even though it's a number and I'm using a string, it coerces the value into that type, right? What's on the left. However, if I use the triple symbol, you notice that Frank will not show up at that point anymore because the types have to match. That's the reason that you use the triple symbol there. So that's your if statements. I'm not going to get much more into that. You can play around and look at the different conditions, but just know that you have that. But now you also have the else statement, right? So you can actually have an else. For example, if you could say else, right? And then you could say console.log right? So you can say, for example, that whoever that person is not valid, right? So let's see, in this case, Joe's not valid, Frank is not valid, Red's not valid. So no one is valid. Okay, so now let's see if we remove this, Frank will be valid. And we can just say, so you notice Joe's not valid, but Frank is valid and no one else is valid. So, but that's the else statement. And so that means it's going to execute this. And if this is false, then it's going to execute that. One thing that I didn't mention about the if statements, right? Now, once the condition evaluates, it stops executing the rest of the conditions. For example, if this and something else is going to have to evaluate both of those, because in order for that to be true. However, if I said this, if person's age equals 21 or something female, once this evaluates to true, since it's an or statement, if this is true, it's not going to evaluate the second part of this. Keep that in mind. That's very important. So in this case, what if we had something else? Before that, we could have another else if statement. And else if requires a condition. So if they're 21 for example, it'll execute that. If it doesn't execute this, if this does not go into the body of it, it's going to then go to the next portion of the if statement, and then it's going to execute that. So like, for example, here we can say or equals 15, and then we can say right. So if the age equals 15, which would be Mary, and it's not gonna, she's still gonna be valid. She's not gonna go into this because it's that. So what am I missing here? Name plus 15. For some reason, it always wants me to enter the new line, even though there is already a new line. So it's going to say that this person is 15. So in most cases, it's going to execute valid. Frank is going to be valid. Mary is going to be 15, and everyone else is not valid. So let's take a look at that. Okay, and there you are. So those are your if statements. If statements, just keep that in mind for this, and keep coercion in mind because that's very important. We haven't gotten into truthy and falsy values, but I do plan to cover that because there are truthy and falsy values, but they deserve a lecture of their own. So we're not going to get into that. Let's see what else we can get into with this. So one thing about strings, okay, let's go back into the strings, right? Because strings are very important in any language that you use, and most of the time the data that you're going to be working with are going to be some sort of strings, and you have to do a lot of different things with strings. So let's take a look at strings really quickly. So let's say we have a string, right? And a lot of your exercises, if you go on those other websites where you have code wars and things like that, there's a lot of exercises with strings. So let's just take a look at strings. Let's say we have a name, and we have, right? So strings in JavaScript are very rich. Now, I said that a string is a primitive, and there's two different ways you can look at strings. We have this string, and we have, let's say we had a model of a car or something. But instead of declaring it this way, we are going to declare it as a new string, and we declare it this way. Now, watch what happens when I do this. Let's see, say type of name, and then I say console.log type of model. Watch what happens. See, one is recognized as a string, and another one is recognized as an object. And this is a little quirk in JavaScript. And the reason I say it's a quirk because in reality, I don't know if it matters. I guess it would matter depending on how you're passing the string around, but still strings are immutable, so you can't really modify a string. The thing about it is that if you're looking for the type, you got to be careful. Like if you're looking for a type of string and it doesn't come out, and then it's like, well, wait a minute, the other one is an object, and you're looking for type of to see if something is a string and it returns an object, you may have some logic flaws there. But the thing about it is that the strings have a lot of functionality. So if you look at the functionality of strings, let's go back over here to Mozilla. And let's see, built-in objects. Where are the strings? Boolean date error. Number in. Wait. Sometimes it's faster if I just type string JavaScript. If I do that and I go to Mozilla, then it takes me to string and I can see all the properties. You notice that string is really, really rich in functionality. So you have all these things available to you in a prototype. So you can actually, some of these, I'm not sure how they work because, like, for example, italics and that sort of thing, I'm not sure how that actually works. I imagine that only works with a DOM. But some of the things that you can do, like split a string, if you wanted to split a string, let's take a look at that. Let's say that we wanted to split the name. What will that do? And we want to split on space, right? So you notice that now when I split my string, I split it into an array. These square brackets are for array, and I've split the string into Joe Smith, right? And you can actually tell it what to split on. And if you had like words, for example, you had a list of words and you want to split them, well, that comes in handy. There's also other things like finding a substring within a string. Sometimes you want to find, and that's where index of would come in place. So for example, if I wanted to find out the index of Smith, it should give me the index, and it gives me the index 4 because 0, 1, 2, 3, 4, and it's telling me that Smith does exist within the string. And if I was looking for something else, like if I was looking for Smith, and this is case sensitive, it's not going to find it, and I think it's going to give me -1, and it does. Basically, it says I didn't find Smith. Now, what if you wanted to find Smith and you had mixed case, but you didn't care about the case? Well, that's where what does it make upper? Let me look at the where is it? Here, oh, two upper, two lower. So you can say 2 uppercase, 2 lowercase. So you actually say 2 lowercase. And now, and it's a method, so I have to do that, and it's going to give me that, and it's going to find Smith again because I've converted the string to lowercase first, right? And then that. The other thing about strings is that strings are immutable. You cannot modify a string. Even though a string can behave like an array, let's take a look, for example. Let's say that I wanted to get the 4th letter of Joe. So let's say letter, right, equals name. And I want the 4th letter, which is index 3, 0, 1, 2, 3, which would be the space. Well, no, let's not do the space. Let's do the 5th letter, which is S. And if I say console.log S, it should give me uppercase S, right? And I could, not S, letter. So it shows me the letter, right, S. However, I cannot modify the string, even though it behaves like an array, and I can loop through the array. So for example, I can say something like this. I can do my for loop. Here I have a simple for loop that loops through all the letters in the name, right? And it behaves like an array. And you see it behaves like an array. However, even though I can do that, I cannot modify the array. If I say name I equals A, it's not going to modify it. It's going to ignore it. You notice that it didn't change my array. It did not change the name because you cannot modify it. A string is immutable, so you cannot change that. Okay. So, and if you want to know what are all the things that you can do with a string, just look at the official documentation. It's very simple to use: to uppercase, trim left, value of. I mean, there's just so many different things. You can take and check if it ends with something, concatenate. You can find out what character is at a certain index. There is, what was I looking for? Got to be careful with these two. They behave differently. If you want to get a substring out of a string, you can tell it. For example, substring, you tell it where to start and tell it where to end. Whereas sub str, well, you tell it at the beginning through the specified number of characters, and you tell it how far to go. Notice the other one, you tell it beginning and end. This one, you tell it the beginning and how many characters from there to grab. So, but there's a lot of functionality in strings, and just know that they're there and know how to use them when you need them. What else about strings? I think we've covered everything that we're going to cover with strings, and I think that's more than plenty, really, for strings. So let's leave it at that for now. Let's leave strings as they are for now, and let's get into something else. So there's this concept called hoisting in JavaScript. And hoisting is kind of unique. I don't think I've seen it in any other language, but the idea is very simple, really. So when you have hoisting, you have this thing called the scope, the context, right? So when you have functions in Java, that's your scope of a variable. Like, for example, in C# or C++ or anything, you have block scope. For example, let's say we have a function, and let's call it foo, for lack of a better name. So if you have foo and then you have an if statement, if true, we just put a hard-coded true, and then you say var x equals 10. I can actually, in another language like C or something, or C++, this would be declared here, and it would not be accessible outside of this if statement. However, in JavaScript, it is. As you can see, when I do this, you notice that it accesses X there. So it's almost as if I had declared X up here. If I did this, and then I did this, notice that I declared it here and I assigned it here. And watch what happens when I do that. It behaves the same way. It's still going to execute. However, there's one thing about hoisting, and that is that if I do this and I log X here, it's not going to give me X. It's not going to have the value 10. It's going to actually be undefined. Notice the first one, which is this one, is undefined, and this one has the value, because that is as if I had declared it but not assigned a value, because it separates it, and that's because of hoisting, right? So hoisting goes by function. So for example, if I had another function, I can define functions, and I didn't cover this earlier, but I can define a function within another function. And I can say var x, right? And or var y equals 10. And you would think that it would behave the same way. I can say console log y. And what happens in this case? Well, let's take a look, because this is actually going to give us an error. And it gives us an error because y is not defined, because hoisting in the scope happens from function to function. So this function here, this y is hoisted inside of bar because bar is a function. So it doesn't get hoisted inside of foo, it just gets hoisted inside of bar. And that's what happens with hoisting. So you got to be careful about that. One thing you have to be careful about hoisting is sometimes you may have a certain intent and it doesn't really work like you expected. For example, if you have a for loop, and let's say I have an object. I'm trying to contrive an example. I'm not sure if I'll be able to pull it off. So let's say that I have an object equals so the hoisting here, you would think that I'm initializing this every time. I don't know. Am I? I don't know. So let's take a look. So if it's that, let's change it to var.name equals David. Otherwise, don't change it, and we console.log. Let's see what it does. And we execute this. Let's clear it. Oh, we don't want that. We want console log var name. We don't want that. So I guess it is initializing it. It is executing this line every time. It's those hoisted. It kind of does some quirky things because it's assigning it Joe initially. When it's even, it does David. When it's odd, I'm not sure if I can come up with a good example. Just beware that it's there with hoisting. There's some traps that you may fall into. I can't think of any off the top of my head, but there are some pitfalls that you may land in. For example, if you have bar here and you want to find it elsewhere, I'm not sure if you can pull this off where, I don't know. I just can't think of any. So just keep that in mind with hoisting. There's this concept of truthy and falsy values in JavaScript. And the idea is that you can execute certain things. So for example, let's say that let's have foo and let it determine what is truthy and falsy. So we can say something like if x, and we can write console.log x is truthy. In other words, it evaluates to true, else we can say console and we can do that. So when we pass in values into this, we can find out what is truthy and what is falsy. So if we say foo, let's pass it 0. Let's pass it. Well, let's make sure that it executes first with that. So 0 is falsy, means it executed this second part. In other words, 0 evaluated to false. So what happens if we pass it an empty string? Empty string is falsy. And what else is falsy? What if we pass it something that is not a number? For example, we said 5 plus a. That should give us an AND. So let's do that and see. Oh, 5a is truthy. Oh, that's because they coerced it. How can we get an AND? I think in order to get an AND, we can do something like, let's see, string to number in JavaScript. Parsing. Okay, so let's do that. So we were to say parsing, and we try to do an A, it should result in an AND. So, and nan is falsy. So what else is falsy? Undefined and null. So we can pass it null, foo, null. So what about undefined? What do we pass it? What if we were to pass it var a, and we pass it a, and a is undefined? Whoa, reference error. Full. Okay, no, it's not full. Undefined is falsy, null is falsy, nan is falsy. All these values are falsy. Everything else should be truthy, according to this, right? So you can get in a lot more detail about falsy values, but just know that, because sometimes you may be expecting, you may fall into a trap sometimes, and I've seen this happen, where you have JavaScript and somehow you didn't convert your values over, and you're trying to execute something like this. And what ends up happening, now if you were to do a comparison, that would be false because it will coerce it into false. But in this case, false is going to be falsy, right? So you think, okay, actually false, the word false is truthy, which is not what you expect. False is truthy. So be careful with that, because only these values, 0, empty string, nan, null, and undefined, are falsy. Everything else is truthy. So keep that in mind. Now, another thing is the concept of coercion is pretty interesting in JavaScript. And coercion, the idea is that things get coerced into other values, right? So, and that's why you have to be careful. So if I have a variable, right? Variable a equals false or hello, what happens? Well, remember when we go back in truthy and falsy, falsy is false. So since it's false, it's going to want to execute the second part of this, right? So it's going to assign a to that. So when I say console dot log a, it should say hello. You notice it says hello. Now, if on the other hand, I said var a, var b equals hi or hello, b should be hi because this is truthy. And it should be high because it's not going to execute. Remember, the rules is it's not going to execute that anymore at that point. It's kind of an interesting quirk because you can do some really interesting things. Let's say, for example, that I had in my configuration where something was initialized. So, for example, like say, for example, my connection string. I have var connection string. And my connection string is something. And I say config string, config connection or something. Or, and then I give it, my whatever IP is, 192.16a.1.1 or whatever my database is for my connection string. So depending on what's in the configuration, if the configuration is empty, let's say for example we have a configuration, if config con has been it's empty, if it's an empty string, then it's going to assign it a value. It's like setting a default. So when I say console notice that it assigned that. But if there was something in my configuration, which let's just say 3.3. Let's not do that. Let's actually do something kind of realistic. Whatever, right? So my config con now is going to change to that because it's going to execute this. It's going to be truthy here. It's not going to execute that. So instead of being 1.1, it's going to be 2.3 now. So, and that's kind of interesting. So it coerces the value. So you got to watch out for coercion. And where coercion comes in is in your if statements a lot because, when you have these symbols with the if statements, the values can get coerced because if you say, for example, if config right? Or can you do this? I don't know. I don't know. Maybe that's a bad example. Let's try it. Let's see what happens. Right? But what if I had both strings empty? I have that, or maybe I want both of them to be set. Let's just do that. That should be false. So it should not do config set. So it doesn't do it, right? If this and this because truthy and falsy. Now, when we're talking about coercion, right? We're talking about something like this. When we say 5 equals 5, the value gets coerced to an integer. So I can say true. So you notice it's true, but when I do this, then it's no longer true. And that can happen with like booleans. If I say if false equals false, or let's say true equals true. If true equals true. It didn't coerce true into true. So I guess it doesn't work with true and true. What if I said it like this? True equals true. Will that work? That doesn't work either. So that doesn't get coerced. So you got to be careful with that, with the relying on coercion. So you don't want to rely on that. So it's just best to be explicit about it. It's one of the quirks in JavaScript. Just go ahead and do it. So go with that. That's coercion. We talked about arrays. Another thing about arrays is you have some functions to map things, and you have a lot of functionality. That gets a little more advanced. I won't get into that because it's just supposed to be a crash course on JavaScript. One thing that I did want to cover about JavaScript is the idea of objects. And we've covered objects a little bit, but I wanted to cover them in a little bit more detail because the objects, when you declare an object, for example, the person object, you have the opening and closing curly braces, and you have a bunch of pairs, and you have name, or you could have first name, right? And sometimes to make this seem more readable, you might want to even separate it like this, right? So you separate it, and notice that I'm separating all my values with commas. There's a key value pair. This, the first name being the key, and Joe being the value, last name key, Smith value. So, and I don't have my syntax right. And then you can have other values within it. You could even have arrays within it. So for example, let's say that you had hobbies. And you can have an array of hobbies. And let's say swimming, art, coding. Those are this person's hobbies. So when I can access the values, right? So one thing about it is when you there you've created an object. So when you log the object, you can access the object like this, right? But another thing about objects, you can also give them behavior. So there you've given the object behavior, and now in order for me to say name, I can and you notice I gave it behavior. And you have the keyword this. We haven't discussed this keyword. We will cover it, but not just yet. And don't think that the this keyword behaves the same way as other object-oriented languages. If you come from C# or Java, beware that it's not the same thing, and it can really trip you up. We are going to cover it later in this tutorial. For now, just keep that in mind. So that's an object. There's other ways to create an object, and which can cause a lot of confusion, because if you're not used to creating objects and inheritance, and JavaScript doesn't have that, well, when you create an object, something like this. You can have constructor functions. Notice that in this case, my function has an uppercase P, and that's a way to define a constructor function. And typically what you do is you do something like this. And we have basically created the same object. Essentially behind the scenes it does that, but I can't call this because I haven't instantiated. So what I have to do in this case, I have to say var person equals new person. And now I have a person, so I do that and it behaves the same way. Well, what if I wanted to pass in the names? Let's say for person, I wanted to pass the first name and the last name, and then I just have this, and I say first name, last name. And right now it gives us undefined because I didn't pass anything. So I have to pass that in the constructor. And I have the same thing going on. So that's my constructor function, and I'm defining that function there. And that's another way to construct an object. There's a third way to construct an object, but I won't cover it. I'll let you find out what that is. It's just clue is object.create. Look into it and you will see, and you can figure that out. There's also inheritance, which is a little bit beyond this crash course. I won't cover that either in this short course. If you haven't noticed, one of the things is that in JavaScript, I'm not using any semicolons. Those are optional. I choose not to use them. Just be aware of that. And that's just perfectly valid in JavaScript. It actually makes it a little bit cleaner. One more thing that I like to cover about objects is that an object in reality is nothing more than a bunch of properties. So let's take a look at, I have person here, Joe Smith, and I can actually have another person, I call it, let's say, maybe alien or something, alien. And let's say that I create alien like this as an empty object, and then I can dynamically add the properties. I could actually say alien dot first name like this, and that'll work fine. ET or something, and then I can console. You notice that first name is ET and the object, and I extended it after the fact. So, you can always add that, but that's not really adding to where you have a prototype. It's actually adding it to just this object. So it's not adding it to the prototype. But there's another way of doing this. And I can simply say like this. And that will essentially do the same thing. Notice that it still gives me the same thing. And I believe I can add really any object on this end. So the one thing that I didn't cover about objects is that objects can actually have other objects within them. So, for example, in this person object, I can add more complex objects. I can say this.address equals, and then I can get into street 1201 some street, and state. Right. So I can do this like this, and of course I have to have my commas to separate everything out. And if I was to now access that, I just use the dot notation. So for example, person, I can say address dot street. And you can see how I can access that more complex object. So it's going to have that more complex object there. So you can have that, and you can have arrays, and you can just knit some really deep. That's why it comes in really handy for when you start getting into JSON, which I won't cover in this, but JSON or JSON, it stands for JavaScript Object Notation. It comes in really handy for transferring data, but I won't cover that in this tutorial. So I'm just going to cover these things. I think we're getting there. Let's see what else we could get into. One thing about, and if you come from other languages, that you may be wondering, there's something called closures. So let's save this right now. Let's put it aside, and let me copy the whole thing. Let me copy all of this, put it aside, and put it in on my notepad. So I have the objects. One thing I didn't cover about objects is there's something called closures. And closures, they can be confusing, and they can be very handy, and they can create some interesting quirks as well. So when you have closures, let me give you an example so you can see what I'm talking about. If I have a function and I do this, and I call it foo, then I have a variable x equals 10. And I return a new function called bar. Return x times 2. I have to call the function. So this x is defined here and is going to execute here. But notice this. When I call foo, notice that I'm not executing bar just yet. I'm just getting the function bar. So it doesn't do anything at this point. Even if I was to, it's not going to execute until actually I execute bar. Run over, there's not a function bar equals foo. I executed foo. It returns function bar. Then I try to execute bar. Oh. Oh. I'm trying to type on. So console log bar. Wow, what am I doing? Okay. So you notice that I'm not executing, and it doesn't actually get executed till I call bar. But how does it do that? Well, it holds on to the value of X because of closures. The value will continue to exist even after this function has executed. This is different than what you have normally under Java or C# because this is still residing in memory. This is holding a reference to it here. And the value is not the value that it's holding on to. It's holding on to the actual variable because if you do something like this, and let's just demonstrate. Remember when we created the objects? And so let's say that we had the person object here. And let's say that the person object has some kind of value called age. And we have something called this.setAge X. And what we do, we say age equals X. And we have another function that says get age. And we return age. Right? So, and of course I'm defining this wrong. So it's like we created setters and getters for age. Now age is not accessible outside. So when I say person, I can't say p_age. It's not going to work. Let's do it in the log. It's going to give me an error. It's undefined. However, if I say person, right, get age, it will give me 10. And I can actually take and say p.setAge 20. Now it'll change that value to 20. And you notice that I'm accessing it, I'm having it behave like, encapsulation, because I'm hiding the age in person. And the reason this works is because of closures. There's more to closures. There's certain things you can do, and there's certain examples that you can actually have, and closures can be very powerful if you use them, and they can actually lead to some solutions for some tricky problems. Well, I hope you enjoyed this crash course on JavaScript, and if you liked the video, go ahead and give it a thumbs up. If you enjoy this series, make sure to subscribe so that you can come back for some great free content. Thanks for watching.